Ready for a discussion? Let's talk about the conundrum with system engineering. So what's the conundrum issue with system engineering? So today, a lot of companies are making the transition from traditional mechanical products to smart connected ones. And products that in the past mechanically may not have been very complex are maybe still mechanically simple. However, because they suddenly have electronics, electrical systems like cabling and wiring, embedded software, maybe even connectivity to the internet, have a lot more complexity than they have in the past. So a lot of manufacturers are now facing this product and process complexity, and it's undermining their ability to control costs, to release their design on time, to launch the product on time, to keep suppliers happy and to keep customers happy and make sure their suppliers can deliver on time. So it's interesting because system engineering practices offer a means to mitigate that risk. It's a way to develop an unambiguous definition of the product that spans engineering disciplines, mechanical hardware, electrical systems, embedded software, and make it extremely clear what the requirements are for each. And if you go to change them, what are the implications of changing requirements, or what are the implications of changing physical aspects of your physical architecture? Here's the conundrum though. Model-based system engineering, which is the fundamental concept here, is a great fit. The issue, however, is that the tools and the processes are very complex. They have not been democratized. So today, if you look in the companies that have adopted system engineering, you typically see specialists in silos. They develop a good physical architecture that meets the needs to get the behavior of the system that you want. However, that's typically kind of thrown over a wall after system design or system architecture phase to each of the individual engineering disciplines. And then after that, everybody goes off into their own silo. Mechanical engineers are off designing hardware on their own, using their own processes, with little connection with what's going on with electronics, or what might be happening with embedded software to make sure that there's the right behaviors for the systems. And when you get to prototyping and testing, that's why you're seeing a ton of these failures. So the conundrum is that system engineering is not democratized. It's being used by a small set of people early on, and then that is not kind of flowing down through the rest of product development. And that kind of remains an outstanding issue today. System engineering holds a ton of promise to address these risks, these complexity risks that manufacturers are seeing as they transition to smart connected products. However, frankly, systems engineering is not really accessible today, and there needs to be a new approach. But that's a different video. That's it. Take care. Talk soon.